Okay, everybody. Hey, this is Mr. Hahn. I am in my garage. I'm going to teach you a little bit about the unit circle today. Before we go much further in our trig stuff, we have to get this unit circle down, and it's a way that mathematicians use to understand, or it's a tool that mathematicians use to understand the trig ratios. So the unit circle, when they talk about a unit, that means the radius is 1. Okay, the unit circle means that the radius is 1, and we, to make life easy on us, we set the center of the circle at 0, 0, at the origin. So this unit circle, we're going to set its center at the origin. So I'm going to draw a pretty poor circle here, but we'll put it around there. Well, that wasn't too bad. Okay, so there's our unit circle. Now we know the radius is equal to 1. So since we put this on the xy plane, here's our y and here's our x. Now, what is the coordinate of that point? Just think about it for a second. You're right, that is the point 1, 0. And what's the coordinate of this point? Yep, 0, 1. And what about this point? Well, that's negative 1, 0. And this point is 0, negative 1. Okay, whoop, put my parentheses in there. So that's the unit circle. So now what we think about is we take angles. We have a different color here. We take angles and we put them, one of their rays, the vertex of the angle, or the spinner. Now I think about this essentially as a spinner. Okay, your spinner always starts pointing on the positive x-axis. That's called the spinner in standard position. And then we can rotate the spinner around to point at different spots on the circle. Okay, and essentially what you're doing is you're drawing a radius out on that spinner level. So I'm going to spin this. Let's say I wanted to spin it 37 degrees. I don't know, 37 degrees. So that radius right there, and this right here would be 37 degrees. We'd call it 37 degrees there. Okay. If I wanted to spin it further, let's say I wanted to get crazy and I wanted to go into another quadrant, how far would I have to spin to get into quadrant 2? Remember, this right here is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Okay, those are the 4 quadrants of the unit circle, or of the coordinate plane. How far do I need to spin to get into it? If we talk about angle or talk about degrees, how far do I need to spin to get into that quadrant 2? Well, you're right. I got to spin somewhere between 90 degrees. So 90 degrees would be straight up and down, and 180 degrees. So as long as my rotation is somewhere between 90 and 180 degrees, then I'm going to be in quadrant 2. So let's say I spin, well, let's use another color. Let's use red. Okay. Let's say I spin, I don't know, 120 degrees. Okay. 120 degrees. That's right there. So right about there. This angle from here to here would be 120 degrees. Okay, so that's how we determine our spins into the quadrants in the unit circle, and how we're going to go about that. Now, let's see. Since we've also talked about radians and talking about angles of rotation, let's go ahead and put some of these radians in as well. So I'm going to use my old dirty t-shirt here. Well, no, it's just an old t-shirt, not dirty anymore. I washed it. And I'm going to erase all this stuff, and for now it's not erasing really well, but that's okay. Okay, I'm going to take this in here, and I'm going to say this is again is quadrant 1, and this is quadrant 2, and now I'm going to talk about radians. Okay, so we all know that all the way around, we've already said that one turn, well, in the garage, and I think that marker froze. Okay, one turn is equal to 2 pi radians. Okay, so I know that if I spin this all the way around, if I take my spinner and go all the way around, make one full turn, that's 2 pi radians. Okay, and so then what would a half turn be? So what is this spot here? Because we know if I say rotate to quadrant 3, you kind of have to know the boundaries. We had to know the boundaries between 90 and 180 to get to quadrant 2. We got to know these quadrantal angles, these are called. Okay, the boundaries between the quadrants. All right, so we're going to take this thing, we're going to make it Let's see, what's a half turn? Well, that's just going to be pi radians. So pi radians, this thing right here, this would be pi radians if I wanted to get to there, pi, okay? All the way around 2 pi, okay? What if I wanted to get, well, then what if I want to get to this 90 spot, to the boundary between quadrant 1 and quadrant 2? Okay, well, that would be a quarter turn, which would be pi over 2 radians. So right there, pi over 2 radians, okay? Pi over 2, all right? Now if I want to get into something like 3/4, well, now I just count halves of pi. Here's a quarter turn, so that's 1 pi over 2. This is 2 pi's over 2, which is pi. And this is 3 pi's over 2. So if I go all the way to this boundary right here, that's 3 pi over 2. Okay, 3 pi over 2, counting those halves, or 3 half pi's. That's what we got going on there. All right, so let's actually put something in the quadrant. Let's figure out kind of where these numbers are and how these fit out. Okay, it's going to be beneficial to us to kind of know. I'm going to get rid of all this right now. So what I'm learning about being out in the garage and using markers, dry erase boards, they don't work very well when they freeze, because they kind of freeze on there. I don't know why, or I don't know what happens. But right now, it was really hard to erase that. All right, so let's get our unit circle going again. So we know there and there, and go around. All right, good. So let's see. Let's figure out 2 questions here. Number 1, what quadrant does 3 radians terminate in? Question mark. Okay, what quadrant does 3 terminate in? Well, let's see. I got to kind of pay attention to this thing. Where does it stop? Where would I stop? If I turn this 3 pi radians, or 3 radians, let's see. Well, that's pi over 2 radians. I wonder what that is. Let's see. Let's just do a real quick math thing. Pi over 2 is the same as 3.14 divided by 2, which is approximately, I should say approximately 1.57. So we can say this is 1.57 radians. Now we know that most of the time we use radians. When we use radians, we use it in terms of pi. But if we have to, we can do this in 1.57 radians. All right, so let's go to, let's see. So are we in quadrant 1 with 3 radians? No, we're bigger than 1.57 radians. So that's going to be somewhere past quadrant 1. But I wonder if we got all the way into quadrant 3. So we're at least in quadrant 2. But if I rotate, if I spin the spinner to this boundary, what was that boundary again? Well, that was pi. We know that this thing right here, going to here, would be pi radians. Going to here would be pi over 2, which is approximately 1.57 radians. So where do we really live? We live in quadrant 2. It terminates in quadrant 2 because 3 is between 1.57 and 3.14. So the answer is quadrant 2. So it's sometimes a good idea to be able to know what those are as a decimal. All right, so let's kind of leave that stuff up there. And let's ask a different question. Right? Well, let's ask one in terms of, and this is really good. Okay, I think. Okay, because different families, depending on the denominator, is going to make us talk about the quadrantal angles in different ways. All right, so let's talk about something like 11 pi over, or 7 pi over 12 radians. Okay, so where, let's even go a little bit more than that. Let's go on 15 pi. Let's go 15 pi over 12 radians terminates in what quadrant? 15 pi over 12. Okay, so here's my common denominator thing. We did this. You've been primed for it all the way from the time you were in kindergarten, because you had to compare fractions. Not kindergarten, probably third grade or fourth grade. You want to combine, or you want to get common denominators here. So let's think about this. 15 pi over 12. All right, so I get to compare something twelfths. Well, that's over 1. So what we're going to call this, we're not going to think about a half rotation as pi. We're going to think of that as 12 pi over 12. I just get a common denominator between those two. That works out pretty good. And then this spot, pi over 2, we're not going to think of that as pi over 2. We're going to think of that as, let's see, I need that to get up to 12. So I multiply by 6 on the top and the bottom, 6 over 6. So that's 6 pi over 12. Now I can count again. 6 pi over 12, 12 pi over 12, 18 pi over 12. To get all the way around, I better draw that in black. Get all the way around, because that was 3 pi over 4, or sorry, 3 pi over 2. Ooh, my markers. Come on, marker. Markers are freezing up. That's 3 pi over 2, 3 pi over 2. So then we're in set here. We're going for 3 pi over 2, which is the same as 6 pi over 12, 12 pi over 12, 18 pi over 12, 18 pi over 12. And then all the way around, another 6 pi over 12 would be 24 pi. If I went all the way around, that would get me to 24 pi over 12. So thinking about those, that's kind of important. Now, 15 pi over 12, where does that live? Let's see. Well, 6 pi over 12 would go to here. 6 pi over 12, 12 pi over 12. This would get me to 18 pi over 12 if I got here. So I must be living in quadrant 3. Okay, so there's your introduction to the unit circle. We'll continue on in the future. Control R.